It works. All right, well, we always have too much to say and not enough time to say it, and so no surprise there, but try to be brief. This is our third year coming here, so the introductions will be super brief, but we have colleagues on the continent now, so we need to mark our peers somewhere. But they'll come back and we'll make sure they get up and tease them. So we're coming from US, but we've already been doing projects in Southeast Asia and Latin America and other places. I think in order to just kind of set everything that I'll show in proper context is that we spend a lot of time and effort to make sure that whatever we're building and doing and proposing is aligned with the world at large, and certainly that's represented by not only the NMHS but also the WMO and its membership. So we have a whole sort of compliance thread where we monitor what we're building relative to standards, requirements, frameworks, and there are a lot of WMO frameworks and a lot of things that WMO members need to do to kind of advance and do so in unison. So I think the most important one to mention in this context is the public-private engagement one, which was adopted, some years ago now, that is one of the key things. But think of us as an innovation partner, really across the technology development value chain, because we've been lucky enough to raise enough funding to be able to invest in all three of these areas and really bring to users, and often kind of leapfrogging and bypassing a lot of bureaucracy, straight to validation and straight in the hands of users, understanding that there is a climate emergency, irrespective of what people in my hometown say, and how you can access information from us and how you can utilize our services. We have a software platform. It has a lot of usages for national agencies, particularly national hydromet agencies. It's really designed to be as flexible as Microsoft Excel in the sense that you can build it to the use case that you have. And we have done that with many mission critical organizations that I'll show examples of. But it's about anticipatory action. It's about kind of real-time alerting and using information that is available to distribute alerts as widely as needed. It's about seeing everything in real time from different perspectives, talking about these hazards, the weather hazards and others, and ultimately even helping in the mitigation and the coordination of the response to any kind of disaster. The applications really range. We have big agricultural interests that have tailored this platform to very specific integrations with agronomic data and like advisories for suitable planting windows and many different things like that. So even though this is not designed for smallholder farmers, the big commercial farmers benefit from this. And we have partnerships for the smallholders, which we can come back to later. Super standardized aviation. The platform is tunable to full NX3 ICAO NX3 compliance in the sense of a range of features and integrations, both from the outside and the inside of the standardized products that are generated not only by the aviation Mets, but also those in the broader stakeholder community, dispatchers in an airline and so forth. There are huge logistics companies that are using this platform, and it goes into their use case in a very deep way, in the sense that they're able to even integrate their fleets into the platform in real time, so that like airplanes, they see trucks, they also have their dashboard cameras integrated. There's a lot of ways that this platform can serve the national governments as they provide services into sectors. And of course, on early warning, the platform is based on the collection of publicly available information that's in the that's made available by in this case NIMED and others in the region. This is the flood case from some weeks ago, which was quite impactful. I don't know if you can see that very well, but the forecasters there would have information in lieu of having really good radar in the place at the moment that would give them a lot of opportunities to deliver information to early warning information in that particular situation. The platform has an enormous suite of enhancements that are done to it all the time. There are about 10 of them per quarter. It's quite remarkable. It's hard for me to keep up, but fundamentally, every function that the National Hydrology Agency wants, maybe it's daily reporting on a particular set of hazards or a particular area, whatever the case may be. Maybe it's interpretation of different layers into a dashboard. There are so many tools there for the forecaster and those who are issuing communication from the National Weather Service. And in terms of what these platforms have been traditionally, fairly hard to set up, fairly hard to customize. You have to do a lot of training. You have to really dedicate a lot of effort to getting use out of them. At least that's over the last decade or so looking at these. Now you just type in, I'm this person doing this function, and it will come up with an environment that is really intuitive and responds to the needs that are super professional, like in the case of an airline dispatcher. The same is true for various applications from hydromet to agriculture and so forth. A little bit about the modeling that's behind it. So, of course, many NMHS are producing forecasts as they continue to develop their national capacity to be able to do so. There have been a lot of sort of barriers and challenges when it comes to doing that. ML-based forecasting is kind of changing that accessibility. I'll show you, but just in terms of kind of painting the possibilities, at the moment it's possible to spin up different forecast models and ensemble members for different hazards, based on demand, and do it with really high resolution, and do it in a way that enables the forecaster to really, get it right. And these are the types of capabilities that are really kind of changing the game. If you just kind of look at it in technical context, we're launching the kind of regional and local focus model, which is an ML based model. We do physical models all the time, but when you look at these comparisons, if I can get of course, the resolution, the frequency, the amount, the number of models that are running at the same time. But probably the most important thing in a developing Met Office context is this right here, right? Because how many projects have gone on to design and deploy big data center implementations? This is running on a single graphics card. So it's orders of magnitude cheaper, and when you see that it's these types of models are delivering better accuracy, you really start to sort of think about the possible without necessarily all the constraints of having to invest heavily into these types of modernizations. I'll say something really quick about our satellites, because our company has invested a lot in that too. Low Earth orbit satellites. What are they? What are we trying to solve here? The reality is that ground-based measurements are available where they are. There are always gaps, and there's always a need to have more and more observations. Everybody will agree with that. the opportunity to close these gaps for modeling purposes is often covered by satellites. And out of those, probably the most impactful are microwave sounding instruments. So one, we help with the data gaps. Oops. Two, when it comes to revisit rates, there are, of course, public satellite programs out there from EUMETSAT. There are many products that are available, but in terms of actual measurements and how frequent they are, as opposed to like inferences, you'll see that those are once every few hours. And this is another gap. And finally, when it comes to tropical forecasting, I don't need to say myself, but in general, you need models that are producing information now in order for them to catch what they need to catch in this environment. So this is the kind of the reasoning behind the low Earth orbit constellation that we're building. And it's not just that we're building it, the data is already available from it, because the sounder part, which is the passive, is already more than halfway built. And then the precipitation radars, we had 2 on orbit for demonstration. Now we're building big phased array satellites again for low Earth orbit. So how does this play out in Africa? Just kind of, hope you can see. A selection of tropical cyclones from end of last year, all the way through, quite recent in the last 3 months. This information is becoming available. So these are 3D scans of and vertical profiles of these hazards, and they are becoming available with a revisit rate of 2 to 3 hours now, and going down to about an hour. In the next few months, this is already planned and already moving. So I'd love to kind of talk to, Madagascar and Mozambique and South Africa about ways that they can use this for monitoring intensification. That's certainly how it's getting used in the Caribbean and southern United States. So we validated all this. So there's an organization called the Joint Center for Data Simulation that has released a report that has validated all the impacts of the satellite data, specifically on forecast model accuracy. So this is a scientific work that's available. If anyone's interested in that. But the reanalysis, but the validation was against reanalysis, against balloon soundings, many different other ways that this was sliced and diced, and we're getting the thumbs up there. So how this plays out in the context of the continent here, I had a video, but basically on the left you see a kind of classic multi-sensor precipitation grid. On the right you see one that's enhanced with these sounder observations, and you can quickly see the amount of accumulation. There is a huge difference between what a typical model will give you and what a sounder enhanced model will give you. So I talked about the software as a service in the beginning. So that software platform is available. It's fully customizable, integrating local data sources, local models, whatever it is that needs to be brought in from third parties or from the country itself. And then we have a data service available from the cloud, simple kind of standard connection, where the data from all of these satellites is pulled together and made available either to the models of the National Forecasting Center, or if those aren't really able to ingest, these types of observations, space observations, and perhaps, a model on a, desired time scale, so it can be a nowcast or a forecast and so forth. So, and all of that goes into the early one. So that's what I had to share. That's
Thank you very much.